Hi everyone, and welcome back to my kitchen. In today's episode of Kitchen Chemistry, we're going to learn how to make a wood stain. And we're going to do this using steel wool and vinegar. Let's go. Alright, this is everything you'll need for this experiment. Starting with some steel wool. And you can pick up steel wool from any hardware store. This is the one I got. Then you're going to need to get some white vinegar. I just got this from the grocery store. You'll also need a mason jar, and make sure you get one with a lid. And then you're going to need a thumbtack or anything pointy so you can poke holes into the lid of the mason jar. Finally, you're going to need some safety gloves and also some safety goggles. And once you've collected everything you need for this experiment, you're almost ready to go. But before you start, make sure you put on your safety gear. So I'm putting on my gloves and I'm wearing my eye protection. And now we're ready to make our wood stain. We're going to start by taking the lid off of the mason jar. Now before you put the steel wool into the mason jar, I want you to try and spread it out as much as possible. This is going to increase the surface area of the steel wool. A larger surface area means there's more steel wool available for the chemical reaction. And now we're ready to stuff the steel wool into the bottom of the mason jar. And then we can pour the white vinegar into the mason jar. And you want to pour enough that you completely cover the steel wool. I ended up using the full 500 milliliters. And now you can close the lid of the mason jar and take your thumbtack or whatever pointy device you're using to poke holes into the top of the mason jar. We're poking these holes to give the gas that's going to be produced during the chemical reaction somewhere to escape out of. And now I wasn't happy that a lot of my steel wool wasn't in the vinegar, so I ended up taking off the lid and using a wooden spatula to push the steel wool all the way down until it was fully submerged. And then the last step was to reseal the lid onto the mason jar. Make sure you seal it nice and tight. And now that the steel wool and the vinegar are combined in the mason jar, it's time to wait. We have to wait because this is a chemical reaction, and it takes time for the vinegar and the steel wool to react and form the wood stain. So you're going to want to place your mason jar in a well-ventilated room, because I have to warn you, it does smell like vinegar. And now I left this solution for about a week in order to allow the chemical reaction to occur. And now you don't have to wait the full week. I waited until I started seeing a color change in the solution. But feel free to try out the wood stain even sooner. And one thing I noticed as I waited was that there were so many gas bubbles that were being produced throughout the week. These are bubbles of hydrogen gas. And now if you're wondering why hydrogen gas is being produced, let's take a look at the chemistry behind this chemical reaction. So in this experiment, we took steel wool and we combined it with vinegar in order to make our wood stain. And now we want to know, what's the chemistry that's going on here? Well, steel wool contains iron, and vinegar contains acetic acid. So what's happening is we're reacting iron with acetic acid to form iron acetate. And now there was also a byproduct from this reaction, which was hydrogen gas. Those were the bubbles that we saw being produced. But the key product in this chemical reaction is that we formed iron 2 acetate. But what is iron 2 acetate? Well, it's a coordination complex. So we have iron 2+, that's iron in its 2+ oxidation state, and it's coordinated with 2 acetate molecules. There's also probably some water molecules coordinated in with the complex, but the key is that we have iron in its 2+ oxidation state. And now as I was researching the chemistry of iron acetate, I came across iron 3 acetate. So this is iron in its 3+ oxidation state coordinated to 3 acetate molecules. During this chemical reaction, we probably produced a mixture of iron 2 acetate and iron 3 acetate, but the reason I think our wood stain is iron 2 acetate is because iron 2 acetate is soluble in water, whereas iron 3 acetate is insoluble in water. So it's more likely that iron 2 acetate was dissolved in our solution. And now I apologize because I know this is pretty complex chemistry, but there's just a little bit more left. Because the iron acetate itself is not actually the wood stain. The reason the wood gets stained is because it contains tannins. Tannins are molecules that are found in the wood, and they will react with the iron in the iron acetate to form iron tannates. And it's these iron tannates that give the wood its dark stained color. So when you apply the iron acetate solution to the wood, what you're actually doing is reacting the iron acetate with the tannins in the wood to form iron tannates. And now for all you chemistry nerds out there, do you know what type of reaction this is? I believe it's a redox reaction. We have iron being oxidized to iron 2+, which means the iron lost electrons. And then we have the hydrogen ions from acetic acid being reduced to hydrogen gas, which means the hydrogen ions gained electrons. I know there's so much more research I could do on iron acetate and iron tannates, but I hope this brief lesson at least gave you a little bit more insight into the really cool chemistry that's going on within our wood stain. But now let's get back to our wood stain and try it out on a real piece of wood. So here's the wood stain after a week of letting the chemical reaction occur. You can see the color of the solution is quite dark, and that's why I decided it's time to try it out. And what better thing to try my homemade wood stain on than this little gnome that my boyfriend carved when he was 12 years old. So I just took a paintbrush, stuck it in the solution, and painted the solution onto the wood. And you can see the wood immediately starts getting darker. It actually got way darker than I expected. Like, this is a very deep colored wood stain. It actually ended up looking more like a layer of paint on top of the wood rather than a wood stain. I wonder if this is because of the type of wood I'm using, or maybe I just let it react for too long or not enough time. This experiment actually resulted in so many more questions, like, why is my wood stain so dark? What's the ideal reaction time? How can I figure out if this is iron 2 acetate or iron 3 acetate? And the biggest question of all, why does my solution look like this the day after I used it? Like, what is all this stuff at the top of the solution? Now, in my research, I did see that iron 3 acetate has a brownish reddish color. And we know iron 3 acetate is not soluble. So maybe this solid material is iron 3 acetate. Honestly, these are all just theories I have, and I'll probably have to do this experiment a few more times to actually figure out what's going on here. But as the French anthropologist Claude Lévi-Strauss said, the scientist is not a person who gives the right answers. They are the one who asks the right questions. So let me know in the comments. Do you have any questions about this chemical reaction? Thanks for listening, and I hope you have fun making your own homemade wood stain.